Good morning, everybody. Thanks for joining us again on another edition of the Building Smart Energy Efficiency Essentials for Modern Home series. We give a big thanks, of course, to DTE and Consumers Energy for sponsoring this series. And we're, like always, going to wait for some of our other participants to join. So just give a quick pause here, and we will be back very shortly with the beginning of the webinar. Okie dokie. All right, we are back at it. Another week. We're getting to the final countdown, folks. We have, I believe it's just 3 more webinars in this series. Hard to believe. This has been a great opportunity to be a presenter here on behalf of DTE and consumers, really helping level up the knowledge of our participants when it comes to all the world of above code programs and how builders can strive for better here in the state of Michigan to achieve better results in higher performance homes here in Michigan. Today, we're going to be switching gears a little bit when it comes to what we've been discussing. Thus far, we've been focused primarily on single family homes and perhaps duplexes or townhomes. That's really kind of the sweet spot for the DT and Consumers Energy new construction program. But there are companion programs within these federal programs for multifamily buildings. So both the DOE Efficient Building Program, formerly known as ZERH, Zero Energy Ready Homes, and EPA's Energy Star program have programs that are focused specifically on the multifamily sector. They're kind of like the single family programs, but with some nuances. And so we're going to go and touch on these programs as well. So we're going to be starting with Energy Star because that's where our compass is. We get started with Energy Star because that's sort of the baseline, and then ZERH, or efficient buildings rather, goes ahead and dog piles on top of that. Of course, I am Chris McTaggart. I'm your presenter. I've been presenting the lion's share of these webinars over the last several months. I am the principal, co-principal, and president of Building Efficiency Resources based in Detroit, Michigan. I love my home state, been living here the vast majority of my life, moved away, came back, and I'm happy to be here. Presenting to you, our company focuses on residential and multifamily new construction quality assurance and training. And we've got several raters all throughout the state of Michigan that are really helping builders level up their games. So, Energy Star Multifamily New Construction, ESMFNC. So it's kind of like the single family program. So it's sort of, you could call it a companion. Same premise as the single family program, wanting to be 10 to 20% more efficient than a code baseline. Historically, the way this worked was, I'd say when I really got my career started in this industry 17 years ago, just about, Energy Star single family was in the version 2 program, and there started to become more, especially in the affordable housing sector, more programs that were asking for buildings to be demonstrated as energy efficient, and therefore they specified Energy Star homes certification to be met even on apartments. What was challenging about that was that the HERS standards, the ResNet home energy rating standards that underpinned the calculation procedures for Energy Star version 2, specifically said that the standard was for dwelling units that were up to 3 stories in height. Why? Well, because if you look at the difference between the IRC, the International Residential Code, and the IBC, the International Building Code, the residential code really specifies that it's really for buildings up to 3 stories in height. And as such, the HERS standards were written commensurately. And as such, the focus for getting HERS ratings on apartment buildings was for dwelling units in basically buildings that were up to 3 stories. And what did you do if the building was 4 stories? Well, you weren't supposed to use HERS. Even though the dwelling unit itself was only whatever 10 feet tall, 9 feet, 8 feet, whatever you want to call it. Basically, you weren't supposed to use HERS. There was a confusion about, can I model the whole building and get a HERS index? So, REMRate was the big software of the time, and you could actually do a whole building energy model, and you might still be able to, I'm not sure, but you used to be able to do a whole building model and say, well, this whole building has 50 units, and you would basically describe the entire exterior shell and the interior surface areas, et cetera, et cetera. It was pretty complicated, and that's not really what HERS was for. Really wasn't for assigning a score to a whole building. So that was confusing. It was clarified that that's really not what you're supposed to do. You're really supposed to, if you're going to do HERS ratings on multifamily, you got to do it focused on individual dwelling units, so apartments, basically. Okay, well, that was easy, but you can only apply it up to 3 stories. Well, Energy Star started to hear from constituents that, look, there are buildings that are really darn close to a 3-story building, but they're a little bit taller. Can't we use the same HERS methodology on those buildings? So the Energy Star single family program started to be applied to dwelling units and buildings up to 5 stories. And so then what do we do about 6 stories and up? Well, there just really wasn't a federal program that applied to those buildings until 2011. So, again, I got my start in this industry in 2009. So, really, frankly speaking, I'm talking about the history of this gap period where we didn't know what to do with 6+ story buildings. The way it was resolved was Energy Star created a multifamily high-rise program, not at all HERS based, no HERS ratings. It was all based off of either a prescriptive methodology or ASHRAE 90.1 whole building energy modeling. And then 5 stories and less could fall under single family homes with a couple of caveats. So the challenge there became that the premise for participation was kind of vague for Energy Star multifamily high rise. Like who was the verifier for it? It was kind of like they didn't really say. So it wasn't HERS raters specifically. It was kind of like anybody who's qualified could be the verifier. Long story short, it didn't cause there to be a lot of uniform sort of understanding. And it also meant that in, let's just say, the multifamily high-rise program was a comprehensive whole building program. It focused on not just dwelling units, but also common spaces. And the whole building modeling approach factored in things like podium slabs and tuck under garages, heated garages, plenum spaces, thermal bridging elements, balconies, things that are very whole building, big concrete and steel building in nature. Um, the high rise program had elements that focused on that. Well, guess what? It turns out that there are still those same elements even in 5-story and under buildings. You still have tuck under garages, you still have podium slabs, you still have a lot of things that are more big building like, and they cause big building energy use issues. You still have common spaces that use energy, and basically all that was being ignored in the HERS single family Energy Star approach. So the EPA decided to create a consensus Energy Star multifamily new construction standard in order to basically say anything that's basically an apartment building, doesn't matter the size, 2 stories or 20 stories or 100 stories, doesn't matter. You can follow the Energy Star multifamily new construction program, and then anything that's low rise in nature, anything that's a house, a duplex, or a townhouse, under most circumstances, can follow the single family program. And right around, the reason why they were able to do that was because the ResNet 301 calculation standard for calculating the energy rating index, or the HERS index, was updated to reflect that you could rate dwelling units in any size building. So you could take that 100-story tall building and still rate an apartment inside that building using the ERI methodology. So that's what the big value proposition of MFNC is. And it has been required to be used for new projects as of 2020, middle of 2021. So basically, anything that's probably in the ground or in planning right now, more than likely, is going to be certifying using MFNC if it is an apartment building. There's the vague possibility. I mean, I worked on a project that just closed out at the end of last year that still it was able to certify under single family homes because it came in just under the window, where that permit cutoff was permissible. So anyways, long story short, that's the thing of the past. Now we've got a pretty clear delineation between single family and multifamily. There's the long-winded history in case you cared about it. And so, basically, it's pretty clear how to divide up Energy Star. And by virtue of dividing Energy Star, we also have the rules of engagement for the DOE efficient building program. So single family detached, so like my house, I live in a single family detached home, that qualifies under single family. A 2-family home, so a duplex, that would qualify under the single family program. And then most townhouses, I say most because there are some caveats. If you have ones that are like top to bottom, so you've got a configuration where someone enters in at ground level and then they enter their unit and it's above somebody else's unit, Energy Star wants those to be considered to be under MFNC, even though they may be part of a broader development that may otherwise qualify as townhomes. So, for example, I know of a project here in Detroit that I'm affiliated with that has a bunch of townhomes lined up, but then the end units are top to bottom. And so the top to bottom ones, those have to fall under MFNC. And so it makes more sense to put the whole thing under MFNC. That's the only place where this gets a little bit confusing. Otherwise, it's pretty clear. Apartment buildings fall under multifamily new construction. And anything that's small falls under single family. So I'd say 95% of the time, the decision tree is pretty darn clear. When you get into these kind of low rise, otherwise residential developments, but you have stacked townhome configurations, this is where the EPA has drawn its line. Personally, I've encouraged them to be willing to accept that these projects may be better off in the single family program, but henceforth they have not gone for it. Okay, so where do we stand nationally with MFNC? Well, basically, currently everybody other than the regional programs is on version 1.1. Version 1.2 is slated for adoption in some of the early adopting of advanced energy code states like the Pacific Northwest, like Massachusetts. Well, actually, Massachusetts isn't on there. Interesting. Connecticut, Maryland, Virginia, Florida, Illinois, and Ohio. Okay, yeah, because Ohio updated its commercial code to a more advanced code. So, anyways, unlike the single family program where the EPA is really looking at the adoption of advanced versions of the IECC residential code, for MFNC, they're looking at advanced versions of the IECC commercial code or advanced versions of ASHRAE 90.1 as the code. So for these advanced versions, 1.3 is defined, but nobody is required to comply with it at this point. The way that MFNC works is it's a little bit different than the single family approach insofar as you've got three potential paths to success. You have the ERI method, which is essentially the HERS index method. That's very similar to what we do with single family homes. It's just that we're really focused on modeling dwelling units, not so much, the whole building. Gets a little bit tricky when you get whole building systems like whole building heating, cooling, or ventilation or water heating systems. You have to think critically about that. And then there's ways to consider modeling some of this stuff that's a little bit trickier, in terms of over podium slabs, potential structural thermal bridges like slab edges that go to balconies and how you model that, so that you're supposed to factor that stuff into the HERS approach. Regardless, ERI is one method. Those would typically be done, the modeling by resident HERS raters, and then all of the inspections and testing by HERS raters. The ASHRAE 90.1 approach is a whole building energy modeling approach. And it's using software like eQuest or Design Builder or IES, amongst others, Energy Plus. So you can use essentially, ASHRAE 90.1 as a whole building model. Generally speaking, those models are not going to be done by HERS raters. There are some HERS raters that are educated in how to perform whole building modeling. And so there is a niche there, I would say, within the ASHRAE 90.1 world for raters to be modeling. There's also a non-modeling approach for Energy Star multifamily new construction, which is the prescriptive approach. Basically, if you meet certain criteria that on a prescriptive basis, so certain building assembly R values or U factors, window U factors, mechanical system minimum efficiency values, as well as a few other elements, then you can actually just not even do an energy model at all. Both the ASHRAE and the prescriptive paths are, instead of being certified through the HERS provider methodology, they use what's called an EPA multifamily review organization, or MRO. So for example, my company, BER, we're a resident HERS provider. We work with 500 raters nationally, and many of them are submitting multifamily projects for Energy Star compliance using the ERI method. But then we are separately a Energy Star MRO organization, and we're receiving projects using the ASHRAE method or the prescriptive method. I would really recommend, too, for those that are participating, don't sleep on the prescriptive method. If you're not familiar with it, if your project qualifies, it definitely can save some time and complexity and potentially cost as well. So besides these paths to success, there are sort of mandatory requirements, just like, just like you would have with the single family program. I wouldn't call them mandatory minimums because then you start thinking about Bill Clinton in the 1990s and sentencing laws. But mandatory requirements of the program, you have to meet them minimally, I suppose. So it's all good. Regardless, verification and quality assurance. Okay, so who does that? It is explicit that it is ResNet raters or equivalent. There are, as we know, anybody in the industry, there are a couple of sort of ResNet competitor organizations out there, but by and large, it is ResNet HERS raters doing this work. They have to be trained and certified on Energy Star multifamily new construction, and then they can participate in this program. All right, so the mandatory requirements. Again, you got to meet those minimum mandatory requirements minimally. So again, depending on which path you choose, let's take the easiest, in my opinion, path, prescriptive. There's no modeling, but you have to meet the specific requirements as defined by the EPA. ASHRAE 90.1, again, you have to take somebody with a little bit of a sophisticated energy modeling background to do this, and then it has to be reviewed by a modeling reviewer through an Energy Star MRO. There's not that many of them out there, but I would say this gives potentially more flexibility because there's more ways to get credit for some of those whole building and common space features that are tricky to get full credit for in the ERI approach. Again, I would say most raters are still doing ERI because they're used to it. They're used to doing, you take a whole building with 10 different unit types, you model each unit type, you do all the different configures, east, west, south, north, top floor, bottom floor, middle floor, end unit, interior unit. And you model all these and you figure out what the worst case units are. And then basically, as long as those worst case units meet the ERI method, you're good to go. Using that ERI method, relative performance, version 1.1, which is required for current participation in Michigan, is probably going to be somewhere in the 55 to 65. And, the tax credit, yes, the 45L has been an option for Energy Star multifamily new construction. And it depends on the acquisition date. Could be 1.1 or 1.2. Long story short, this is sunsetting at the end of June, so I'm not going to spend a lot of time on that. You can be next gen actually as well. As we discussed a handful of weeks ago, next gen is a companion version of Energy Star single family that is focused on all electric buildings, amongst other things. And it can also be applied to multifamily, but you have to have at least version 1.2 or 1.3. Generally speaking, the ERI scores are going to be more aggressive in the 40s or low 50s. If you use the whole building ASHRAE modeling approach, then for version 1.1, you have to be 15% better than the 2016 ASHRAE version. 1.2 is 15% better than 2019, and 1.3 is 15% better than 2022. You can potentially, if you're doing a passive house project, showing sufficient savings in WUFI modeling could be an option as well. But essentially, this is what you're having to do in order to demonstrate compliance. Prescriptive, you don't have to do any modeling. No ERI, no whole building modeling. Basically, you just have to meet the as defined prescriptive requirements of the program. Again, I wouldn't sleep on this. I know it doesn't feel very rater like. We want to get out our software and model things, but man, it makes it a lot easier if you can just be focusing on inspections and testing and not necessarily be trying to model everything and track all the variations and what happens if they specify the wrong thing and how is it going to work in the model. And there's just a lot more stress and anxiety with multifamily modeling, in my opinion. So if you can skip it, I'd say skip it. How do these two programs sort of stack up in terms of their kind of key variables? Well, again, we talked about the differences in the decision tree for what building applies. We'll skip that one. Um, Single family, you only have one option for participation. That's performance using the ERI method. Versus MFNC, you have these three options. For single family, there is the option for a HVAC contractor to be credentialed through the EPA to perform a commissioning checklist on installed HVAC systems, or the rater can do HVAC grading. And under MFNC, you have to have a functional testing agent that does this testing. And again, HVAC grading may apply, kind of depends. Some of the whole building systems, you need to have somebody who's willing to do that work and credentialed to do it, I should say. Um, Under single family, there's no common space requirement. So let's say you've got a duplex and it's got like a one door entry from the exterior, and then it goes into a small corridor that provides independent access to each dwelling unit. From there, you don't have to worry about what that common space looks like. Or if, let's say, you got a whole gang of townhomes and they've got some type of exterior access point, a common hallway or some other amenity space, you don't have to consider that. Under MFNC, you do. Under single family, there is both total duct leakage and leakage outside requirements, whereas under MFNC, you only have total duct leakage. And in single family, we pressure balance all the bedrooms to plus or minus 3 pascals. And in MFNC, we're only pressure balancing bedrooms with 150 CFM or more of supply. So if you've got relatively low delivery of airflow in a bedroom, you can skip that pressure balancing. So, I still think it's a good idea to do that in multifamily, but you can skip it according to the EPA. Okay. Here's how partnership works. Designers can participate. Modeling consultants, obviously, that's pretty much a rater, but if you're going to be a whole building modeler, you have to have a credential to do it. HVAC designers don't have to have a credential necessarily, but it's a good idea if they do. Builders and contractors do. You do have to have participation. There are credentials for, obviously, raters. They have to have a partnership agreement. Functional testing agents, they just have to meet certain credentials. Again, an HCO, or home certification organization, focuses on homes, single family homes, they're following the single family approach. Or if you're doing the ERI for dwelling units in a multifamily building, then the oversight organization would apply. And then an MRO would apply if you're following MFNC using the prescriptive or ASHRAE 90.1 approach. And that basically this same construct applies for the DOE program as well as the EPA. Okay, so here's a tip for success. Having been through this, don't just focus on the ERI scores. As raters, don't just focus on that, because if you do that and you skip the checklist, you're gonna miss something important. Because with MFNC, the devil's in the details. There are a lot of mandatory requirements of the program that you have to be aware of. And if you miss those hard requirements, you just flat out may not be able to participate in the program. So it's not just about the score or the model, it's about the devil in the details. So you want to bust out these checklists early on, and you got to comb through it. I've done it with projects, and you find things that are specific to the program, especially the common space stuff. Tuck under garages, plenum spaces. And if you don't know what a plenum space is, you got to start to learn. If you're a single family rater trying to step into this program, or a builder trying to step into this and you've never really participated, you got to learn what this stuff is. There's limits on the amount of electric resistance heating you can have in amenity spaces like stairwells. That's new, that's different. So they can't just put in a super high consumption electric resistance heater in a stairwell. Why? Well, because it's overkill. So the program has specified sort of maximum consumption values for some of these spaces. Janitor closets have to have exhaust, local mechanical exhaust. I've had to flag that for projects. The common spaces need ventilation per ASHRAE 62.1. Again, that's not always happening in conventional construction. You would assume that people would be putting in ventilation in common spaces, but they aren't necessarily. So there's a lot of devil in the details that you're just going to have to bust out and really get comfortable with. And I would focus on that stuff first. Yeah, the modeling matters, but what matters is all the devil in the details stuff even more. Why? Because you're probably not that familiar with it. I'm pointing at you, Raiders, and you builders, you're probably not that familiar with this stuff. So you have to get familiar with it. You can't just sort of assume that the engineer has it. Don't ever assume it. And if anybody's an engineer on here, I apologize. I'm not trying to throw you under the bus, but there is sometimes excessive deference to professionals like engineers and architects to know all this stuff. And all I can say is don't make that assumption. You have to really engage the project team early on. There's a lot of checklists. There are design review checklists, radar field checklists, HVAC design checklists, functional testing checklists, multifamily workbook, and photo guidance. There's a lot of programmatic documentation, much, much more than the single family program. So you have to really dive on this and get to know it. In terms of QA, again, you've got two options for how you're going to submit these projects. You can go through your HCO, your good old HERS provider, and your provider will make sure that you modeled things correctly, and then they're going to review the multifamily workbook on the back end to make sure you documented everything correctly. It's kind of similar to the single family program. And then an MRO is really going to be for those ASHRAE 90.1 whole building modeling or prescriptive path cases. And it provides similar oversight to multifamily high rise. Which is now, again, kind of an anachronism. We're not really dealing with multifamily high rise anymore, but that was the predecessor to the multifamily new construction program. Again, this is it. You have to basically be a rater to do the review on site, the inspections and testing. But you are not generally the one doing the model. You may subcontract with someone, or maybe you have someone for your office that is a specialist in whole building modeling, or maybe you just get to skip the model altogether and just go prescriptive, even better. But all that documentation is submitted to the MRO for review, and they send feedback, and that's how the certification QA is performed for multifamily new construction. Okay, so the key scopes: testing and verification of dwelling units and common spaces, inspections, and then functional testing of things like HVAC systems. We have a complete thermal enclosure system similar to the single family home program. Correct load calculations, that are being performed to properly size HVAC systems and then install them properly. Dwelling unit ventilation systems, appliances, system controls, and energy monitoring. These are all elements of multifamily new construction. So how do we look at this? If you've never really done this modeling before, we can see that the blue box on the left is defining pretty much that dwelling unit. It's obviously going out onto a balcony too, which is not part of conditioned space, but regardless, that is a dwelling unit. It has a kitchen, it has a bathroom, and it has a bedroom. That is what we call a one bedroom dwelling unit apartment. And so that would be within our dwelling unit scope. And then the red box are common spaces. We've got a central corridor, hallway, That also has, it looks like, some storage lockers, perhaps, maybe a janitor closet, possibly a trash room. Looks like some elevators, and maybe even a mechanical room. Those are all common spaces, and they have their own individual requirements. Functional testing. This is a big one to pay attention to. It's collected prior to certification, so you actually have to collect it. All the HVAC systems of the building have to be documented. This is not required where the HVAC contractor is a credentialed contractor, but especially when you get into bigger buildings, that's probably not going to be the case as much. But like if you had an apartment building and they all have split system furnace and ACs or split system heat pumps, and you really don't have really big building kind of HVAC, sometimes the hallways are just served, the common spaces, I should say, are just served with pretty conventional systems. In those instances, you don't need a functional testing agent, but you can use a credentialed contractor. So definitely don't sleep on this if you're jumping into a certification approach. Under MFNC, the design review checklist, that's really reviewing the HVAC design report, in particular, as well as the plans to make sure that the building enclosure appears to meet the programmatic mandatory requirements for building enclosures. When we get into the Raider field checklist, we're going to be looking at all the insulation in the building. So grade 1 insulation or grade 2 with continuous insulation is going to apply similar to single family. Prescriptive path has some window to wall ratios. You may say, well, why is that? Well, because if we have less windows and more insulated wall, we're going to have a better performing building. A lot of times, big, tall buildings, what do we see? We see big, giant glass skyscrapers. Aren't they beautiful? Sure. Yeah, they look great, but guess what? That means that your whole wall for your apartment is a pane of glass. Obviously, it may be double pane, maybe even triple pane, but still, that's a lower performance assembly than an insulated wall system. So lower window to wall ratios are better, and so prescriptive path has sort of a minimum that has to be met, or yes, or a maximum rather. Metal or mass walls have some specific continuous insulation requirements. So that means, like, if you have a wood frame building, you don't necessarily have continuous insulation requirements. But if you have mass construction, so concrete building, or if you have metal framed light gauge steel framing, then you're going to have continuous insulation depending on climate zones. Again, there's some specifics about garages and plenums. You gotta get into these because these are where the devil in the details are. You might miss something if you don't pay attention to these details. So these images above, let's take a look at this real quick. So, the one image, it's showing sort of, grade 1 insulation in wall framing, as well as maybe over a garage of some sort. So let's imagine this is a kind of a low-rise multifamily development that has, it's kind of like townhomes, but it's got maybe a 1/1 configuration. So there's stacked townhomes. So you might see like a typical garage, like you might see in a residence, as well as, typical wood framed walls. And it's not a whole lot different than single family, but it falls under MFNC because there is a stacking configuration element of it. So you may look at something not dissimilar to this in MFNC. But then, we look at the image here on the right, we see multiple layers of rock wool continuous insulation. And, I happen to know that this project uses a concrete podium construction with light gauge steel metal framing. They actually don't even have cavity insulation on the inside of the apartments. They elected to go with all continuous insulation. And this is an 8-story building. This is kind of what you might start to see more of. This particular 8 inches of rock wool is a very significant amount of insulation. You might not need quite that much for meeting the requirements of MFNC, but still it gives you a good example of the kind of assemblies that you might be looking at, the far extremes. Kind of like a single family house, but technically falls under MFNC versus kind of a big building, 8 stories, steel and concrete, and needing continuous insulation. Air tightness. Now, there is no whole building air tightness requirement. We're not doing a whole building blower door testing on Energy Star multifamily new construction projects. I think that's a shame. I think they should have required it. They don't. We do dwelling unit compartmentalization testing, and for version 1.1 and 1.2, which are really the only relevant versions at this point, you have to be 0.30 CFM50 or less. HVAC equipment and ducts. Look, this is kind of the same old good old stuff. Don't have poor ductwork. I'd say the big thing that's a little bit different than this is that if you have central ventilation, and this says exhaust, but this has actually been interpreted by the EPA to mean also whole building balanced ventilation systems too. So any whole building ventilation systems, the EPA wants us to pressure test that ductwork to ensure that it doesn't leak in excess. This is a little bit tricky if you've never done it before, so make sure that you consult your MRO in order to get some good guidance. Other than that, it's a lot of the same verification stuff that we see from single family. Rater measured ventilation rate is plus or minus 15 CFM or 15% of dwelling unit design values. We've seen this before, right? I guess the difference is you also got to do it for common spaces. Notice that it doesn't say rater measured for item 7.3. So it means somebody's got to do it. Doesn't necessarily have to be you, but somebody has to do it and somebody has to prove it, is pretty much meeting the design. Local mechanical exhaust, same deal as single family, basically the same requirements apply. But I will say there are local mechanical exhaust values that pertain specifically to common spaces, and do not sleep on them. Again, I gave my janitor closet example. There's a specific MFNC requirement for janitor closet ventilation. Okay, you wouldn't have known that, now you do. Make sure you look it up. Appliances under prescriptive, basically it's what you have to install Energy Star appliances, and you have to have basically you can't have multiple shower heads running at the same time. No luxury showers, or you have to have a total gallons per minute of 1.7 gallons or less. So you get, and then in the ERI path, you have to have water sense labeled faucets and aerators and shower heads, but otherwise you don't need to have Energy Star appliances. You may wonder, like, well, this talks about appliances. Why is it talking about water fixture flows? Well, I will just say water fixture flows. It probably would have been better, honestly, on a separate slide, so I apologize. But hot water loads in an apartment building are kind of a big deal. And so the EPA Energy Star program not only doesn't want to save money in terms of appliances, but really some of the savings for hot water are kind of baked in by just using less water. Controls, things like pipe insulation. There's stuff, again, devil in the details. In cold climates where you have certain dampers that open and close for shafts, like elevator shafts or stairwells, you have to consider those. Heat trace systems in freezing locations have to have certain controls. Snow and ice melt systems. So there's stuff that's not in the single family program, and so I'm not going to go into every bloody detail here. I'm just going to tell you, if you're participating in this program, go look at the stuff that you don't know. Don't just get, grade 1 insulation and total duct leakage testing. You already know how to do that, probably. But go and look at the stuff that you don't know that much about and study that and make sure that you're clear on that stuff. Lighting controls. There are specific lighting controls and that are required, and it depends on your compliance path. Note that if you follow ASHRAE 90.1 path, it's a little bit less specific than the ERI or prescriptive path. And you may say, well, why is? Well, because lighting controls and occupancy and things like that are modelable within ASHRAE 90.1 modeling in a way that they're not really in ERI or prescriptive modeling. For big buildings, 50,000 square foot or more, that's not a big giant building, but it's a pretty good sized building. You have to have a method of collecting whole building energy data. And so portfolio manager through the EPA is probably the easiest way to do that. So that's what I would recommend. I'd recommend going in and setting up Energy Star Portfolio Manager in order to collect that data. It's a free system. There's really no reason not to use it. There are other proprietary systems, but honestly, this works pretty good for what we need. Labeling. It's important to understand that with MFNC, all dwelling units have to be certified. You can't just say, I certified one apartment in a 100-unit building. I met Energy Star. No, you didn't. You have to certify all the dwelling units. So in the unit, you're supposed to label in the electrical panel of the unit. And then, it's optional to label the whole building. But the idea is that the whole building is being certified. It's not just the individual dwelling unit, but we do want to label those units. Okay, so what about the DOE program? Again, if you hadn't paid attention in the last couple of webinars, the DOE, in their wisdom, decided to change the branding of the Zero Energy Ready Homes program to the DOE Efficient Homes program. Yes, that was an intentional fart noise because I think that it's an odious branding change. I don't really agree with it. I will say not every building was going to be an actual zero energy building through following the DOE program. So I do understand that much, but I think that the branding personally is not that great. That's my personal opinion. So you're going to notice that I'm going to have slides on here that still show the old branding. And it's not just because I don't like the new branding. It's just that we didn't take the time to update the slides. So just understand, where we say Zero Energy Ready Homes, we're referring to the DOE Efficient Building Program, which is the same basically as ZERH. A couple of minor changes have occurred thus far, but thus far it's pretty much the same deal. With the DOE program, you have to meet Energy Star and you have to meet Indoor Air Plus. Key elements, we talked about ZERH over the past few sessions. It's a better building enclosure, better windows, better consideration of water heating distribution. You can keeping ducts inside conditioned space. More specifics on lighting, more specifics on appliances and electrification readiness, plus indoor air quality measures through EPA's Indoor Air Plus program. Similar deal. There's a single family program and a multifamily program. The decision tree is the same. So everything I said before about comparing which approach to use, it's the same. Energy Star for single family, basically ZERH or DOE rather, you have to meet Energy Star single family. Under multifamily, you have to meet the multifamily program. Energy Star multifamily as a prerequisite. Similarly, again, there's 3 compliance methods with DOE multifamily. They're the same program in terms of the mechanics of how it works, dividing between the EPA single family versus multifamily. Same deal with the DOE, same mechanics apply. So same eligibility, elements apply. In terms of common spaces, we followed the Rater verification checklist for dwelling units, common spaces, the Energy Star baseline, building enclosure, duct systems. In terms of keeping ducts inside the thermal boundary, it's only applying to dwelling unit ducts. So you could potentially have whole building ducts that do not meet that threshold. Why? Well, because oftentimes these ducts start on the roof. You have whole building, systems that live up on the roof, and they start literally outdoors. The ducts are literally outside, not like in the attic, outside conditioned space, but literally outdoors, covered in an inch of snow. And so they're not necessarily able to. They're not forcing everybody to keep all building ducts inside conditioned space at this time. In terms of the pathway specific stuff, there are bifurcation in terms of requirements for building envelope measures, depending on whether you go ERI, ASHRAE, or prescriptive. So devil in the details, same kind of stuff applies. If you want to go prescriptive, which again, I'd say is for a professional doing the work, it's enough to analyze the plans and work with your clients and go on site and make sure they're doing all the things and do all the testing. That's enough, let alone not having to do modeling and then tweaking the model, etc. Try to do prescriptive if you can, because honestly, it makes a lot of sense. But just know there are some very specific elements that have to be met. Whereas with ERI and ASHRAE, there's a little bit more flexibility, but not entire flexibility. You have to meet insulation levels that meet the 2021 or 2024 IUCC levels if you're doing ERI or ASHRAE. So we can't, for DOE, we still have to have better building enclosures. Similarly, got to meet the mandatory requirements. You have to, if you're going performance, meaning either ERI or 90.1 path, you have to meet the performance metrics, and then you have to do verification on site. That's how you get ZERH certification. You have to do both MFNC version 1.2 or 1.3 and EPA Indoor Air Plus version 1 or 2, depending on the permit date, in order to be a DOE multifamily building. We talked about this. The big thing with DOE and its program is electrification readiness, has better indoor air quality, and increased comfort. That's the big thing that you're getting through this program. In terms of how they might stack out from a performance method, the DOE MFNC ERI method is probably going to be in the 40s, somewhere in the 40s. Or if you're doing ASHRAE, you have to be 20% better than 90.1 2019. We've done this before with the other programs. For ERI, your dwelling unit has to be less than the target index for every worst case dwelling unit. Talk to your HERS provider if you don't know how to do that. For prescriptive, your specs for the building have to be better than the target design specs. And for the ASHRAE 9.1, either the energy cost or source energy has to be lower than the 90.1 2019 threshold by 20%. So, if you're going prescriptive and you're looking at what elements you have to meet, you have to go to the tabular data that exists within the national program requirements, and that will basically show you what you have to meet or beat. It depends on the climate zone. So let's say you're doing split system heat pumps, ducted split system heat pumps in climate zone 5, which is where I am. You have to have a SEER of 15.2, and then an HSPF 2 of an 8. So those aren't overwhelming, but there's still things that have to be met. There are specific water Again, in multifamily buildings, you got to understand each dwelling unit has a relatively small surface area of the exterior building enclosure. So things like hot water loads start to make a bigger difference. So there are specific water heating design and then verification measures that apply within the DOE program. So make sure you're checking that out because it's one of the bigger things. For recirculation systems in the dwelling unit, you can only have basically adaptive systems or demand-based systems. You cannot have time or temperature-based systems within dwelling unit. This doesn't apply to whole building hot water recirculation for like the whole building, but there are pipe insulation requirements for that. So, if we have whole building hot water systems, then there's specific pipe insulation elements that have to be met in addition to the plumbing design criteria. Similar to the single family program, when we get into cold climates, so if you're Clare or above here in Michigan, you're going to have balanced heat recovery or energy recovery ventilation systems. And then the big value of this program is we're setting it up to be electrification ready. Interestingly enough, with the branding change and with maybe the change of philosophy in Washington, you would have thought some of this electrification readiness would have gone away. It turns out that it didn't. The DOE program still requires us to be PV ready, EV ready, and heat pump ready if we're not already at the time of construction. That's it, folks. We are wrapped up, and that is the end of our third to last webinar. We will be back next week for our second to last presentation, and we're going to be talking about how we can potentially work within existing homes to achieve better as well, using some of the principles that we've learned from this series. I look forward to working with you all and teaching that lesson here next week. Until then, have a good week, everybody, and we'll talk to you then.